Most of us don't think twice before clicking Update on our software. We treat that progress bar as a sign of security. But sometimes that new package is actually a delivery for something much more dangerous. Consider LiteLLM, a tool used millions of times a day to manage artificial intelligence. It acts like a universal bridge. If a programmer wants to switch from ChatGPT to Gemini, LiteLLM handles the technical translation without rewriting the entire project. Recently, developers who downloaded a standard plugin for their work found their computers suddenly freezing and crashing. While their screens were stuck, the system was secretly harvesting their private passwords and digital secrets, sending them off to a hacker's server. This massive supply chain attack collapsed in just 3 hours because the hackers made a basic mathematical error in their code. Their own mistake acted as a loud, unintentional alarm that alerted the entire industry before the heist could finish. This event highlights the growing danger of supply chain attacks, where malware arrives disguised as a trusted tool we have already cleared for entry. The breach started in the world of open-source software, where anyone can suggest improvements to a project's code. It's a collaborative system where community members submit pull requests to offer new features or fixes. To keep things safe, projects use automated guards. For LiteLLM, that guard is a program called Trivy. Trivy's job is to scan every new piece of submitted code for security flaws before it's allowed into the main library. The hackers didn't try to sneak past the guard. They targeted the guard itself. They submitted a disguised malicious update directly to Trivy for a security review. The automated testing system had a critical oversight. To check the code, it had to run it. The hackers hid a script that executed automatically. It instantly grabbed the master publication token, the digital authorization code, and sent it back. By running the test in an environment that wasn't isolated, the security system accidentally handed the attackers the very credentials designed to keep the project secure. Armed with the stolen authorization token, the hackers uploaded a poisoned version of LiteLLM to the central library where Python developers get their tools. Because the hackers had the correct digital credentials, the library accepted the malicious update as a verified official release. They hid their malware inside a file ending in .pth. This is a mandatory instruction manual that Python programs are forced to read and follow before they even start their main tasks. The trap was set. A developer would download a standard plugin, which would pull the poisoned LiteLLM package into their system in the background. The user had no reason to suspect anything was wrong. When the user ran their code, the .pth file told the computer to create a hidden background worker. This worker's task was to find passwords and send them to the hacker. But the hackers overlooked a fundamental rule of Python. Every time a new background worker is created, it is also forced to read that same mandatory instruction manual before it can start its job. This created a recursive loop. The first worker read the manual, creating a second. The second created a third. Within milliseconds, thousands were generated, taking up the computer's memory, or RAM, instantly overwhelming it and causing a crash. The hackers' own poorly written code created a noisy, destructive loop that instantly sabotaged their silent theft. These system crashes forced developers to investigate their computers immediately. Software failing that loudly leaves a trail that security experts can follow. Because the error was so obvious, the heist was uncovered and shut down in just 3 hours. Without that mistake, the malware could have stayed hidden for weeks, quietly draining data from thousands of systems worldwide. To protect yourself from these types of attacks, one of the best defenses is patience. When a new update comes out, wait a week or 2 before installing it. This allows the wider community to find and flag any hidden issues. Another defense is a quarantine zone, or sandbox. Run the new code inside this isolated digital room first. If a hidden script tries to steal information, it only sees the empty sandbox. Your actual passwords stay safely outside, completely out of reach. While digital attacks are becoming more sophisticated, simple habits like delaying updates and using isolated testing environments can keep your most sensitive data secure.